All right, welcome everyone. We just give you a few more seconds to sit down and get comfortable. So, my name is Håkan, and I'm engineering lead for the input team at Unity.
And I'm Cristiana Moraru, and I'm a product manager for the input system.
And first of all, we just want to say welcome. It's been some fun, exciting, but also intense couple of days. So we're super excited to see all of you here. And what we want to talk about today is how we can prototype, iterate, and evolve a game faster using the input system. Out of curiosity, how many of you have used input system in one of your projects? So quite a lot, a bit over half of you, I think. And how many of you have used Input Manager in one of your projects? Or Unity Input, as it's also called.
The older input solution.
Interesting. So it seems like we have a majority here that has some experience with the input system, and some have used Input Manager. Regardless of what your previous experience is, we're here to show you what is new in input system and also what we can get from Unity 6 when they are combined. And to start it all, let's go to a story that might sound familiar to you.
Let's say that for today's scenario, we have a fun game idea that we want to build for a game jam. In this case, a karting game. Our goal is to first get it set up on PC with a gamepad, and if it does well in the game jam, then we're gonna want to port it to mobile. Let's say we've already designed the car assets, the racing track assets, set up the base scene. And really, we get to a point where we want to set up the player control. So you might be wondering, what should we use to do that? Well, let's go through the two solutions that Unity offers today. On the left, we have the Input Manager, the older input solution. It has been here since day one, and really it provides the basics. But there were just some limitations that we couldn't get past if we wanted to provide new features for you. So we built a new solution, and that is the input system, which now it's not as new. It's still more recent than the Input Manager. And it brings several great features and improvements. But look, you don't just have to take my word for it. Let's compare these two and really break down their features. First up, really the common denominator between them two is that they both provide access to input data, and that is really the key to make the game interactive. Right, Håkan?
Absolutely. Couldn't agree more. I mean, getting access to the data is kind of the fundamental thing to create an interactive experience. If we don't have that, we're kind of, at best, we can do something like linear TV. But it's not only about the data, right? There's more to it.
Absolutely. So that brings us to the second feature, which is input abstraction. And what do we mean by this is that we can define high-level actions and map various inputs to these actions without writing detailed input detection code. And the Input Manager provides limited input abstraction. It allows you to map few physical inputs, such as keyboard keys, mouse movements, and joystick buttons, to virtual axes and virtual buttons. But the input system does take this a step further. It supports processors and interactions, as well as more control types. And we will see more of this in the demo, but really what this allows us to do is to reason about actions and bindings separately, which makes the game scale better. Next up is consistent control mapping across devices. All right, what do we mean by this? Well, for today's demo, let's take that for example, we want to design our karting game so that pressing a specific button on a gamepad will trigger the car to accelerate. Now, ideally, we want this to translate to other gamepads from different manufacturers without us worrying that a different button from the one that we picked will trigger that action instead. Well, the input manager does not guarantee consistent control mapping, which means in that case, you either need to perform conditional checks or write your own rebinding solution. But the input system does provide consistent control mapping for supported devices. And what this allows us to do is that you don't have to worry about how different devices from different manufacturers might map their buttons. And remember how I was mentioning for the input manager, you'd have to write your own rebinding solution. The input system provides interactive rebinding support out of the box, which makes it easy for you to enable players to remap controls in the game. Another feature also only available in the input system is touch-based on-screen controls. By using the on-screen button and on-screen stick, you have access, you can build on-screen controls for mobile without writing any code. And we will also see more of this in the demo. And last but not least, debugging tools, also exclusive to the input system. You can investigate input devices and the data they transmit to the editor. You can also diagnose any connectivity issues, as well as check what devices are connected to the system. All right, and there's even more features that it's worth discussing for the input system, but really, for now, these are the most relevant ones for our karting game. So we'll leave it at this for now, but we think that the conclusion is clear with this comparison. Really, the input manager has been here since the beginnings, is a trusted companion, but really it's limited in scope. And the input system is the solution that we will continue to evolve, and it brings several great features. And it's also the solution that we will use today for the karting game. All right, but we do know that with every new solution comes a steep learning curve. It's worth learning, but of course, if you're on a tight deadline, like during a game jam, it might be more difficult. Well, not to worry, because with the input system's new project-wide actions, you have access to a set of pre-configured actions, so you can start right away and bypass any advanced steps. And we will get this in the demo, so I'll hand it over to Håkan, who will walk us through how to set up the karting game using project-wide actions. Håkan?
Thank you for that great introduction, Cristiana. And let's see if we can jump into the editor here. So, what do we have in front of us? What we have here is Unity 6, and what we also have is Input System 1.9. For those of you who have used the input system, you know that you need to go to the package manager and add the input system because it's an optional package. That's not completely true anymore, because with Unity 6 we have updated the standard templates. So when you create a new project, input system package will be there directly available for you to use. So that is what I have here, but we can also see that there is a lot of other things going on. So what I've done is that I went to Asset Store and found the Unity karting microgame example, and I imported that. That example is currently using a hard-coded version of input mapping to the input manager. I removed that and left everything else almost as is, with some small tweaks. So that's basically what we have in front of us. So now let's see. We have basically a working game already, but there is nothing making it interactive. So let's run this. We have a countdown happening already. There's excitement to get started, but no. It might be super fun to just look at this car, but no, we're not really there yet. So let's try to do something about that. So if I go to the Edit menu and jump into Project Settings and go to Input System Package, this is something new. So this is what we call project-wide actions for short. So this is kind of a glorified input action assets that's there from the get-go. And what it contains is 2 action maps by default, which is some actions in a map called player, that is some pretty common things you might do in a game, and another map called UI, which happens to be some other actions that map perfectly to UGUI and UI to K and allows you to customize how you interact with the UI. For now, we're going to focus on player here because we want some be able to control this cart. So let's try to stick to what we already have. So let's look around. We have something called move here, and we can see it's already bound to a gamepad left stick. That's what we want to use. You can also see it's bound to a keyboard and a joystick and some XR controller. But it seems to fit our purpose. It maps to a gamepad, so let's just rename it to make some more sense. Let's call it steer. And then we find something more, maybe this jump. We can see it's button south, which in my case here maps to the A button, so the south button on the right-hand side. Let's rename that something else then. We may probably want to accelerate this car. And then we pick one more. Let's take this attack. It seems to map to button west, which would be X in my case here. So let's call that brake. So now I have basically just used what's already there. We just gave them some more convenient names. But maybe we also want to have like a pause button or bring down a menu. So we can just add to this. So I'm going to create a new action. Let's call it menu. And let's set up a binding for that. And I'm going to go here and let's take gamepad start. Sounds like a good thing. Let's see that we have it there. Yes. So I have created a new action and bound it to gamepad start. I think we're done on the configuration side now. And the only thing I've done really is changing some names, which I could have skipped, but it's probably going to be easier to follow. And I added a new action called menu. So let's just close this down. But still, we're not there because nothing's magically going to happen just because we have some input actions. So let's have a look at this Kart Classic player. And let's jump to the prefab that is backing this up. So we go here, and we can see we have some scripts on it already. And these basically contain how this kart will behave, handling physics, all of that. But there's no input. So let's add a script. And to save us some time, I prepared a bit of code for this. But don't worry, I'm going to walk you through it. So I added a script now, called it input. And what do we have here? First of all, we basically just get access to this arcade kart, because that's the actual gameplay or game logic representation of the kart. And we want to modify that in our code. On top of that, I have declared, let me make it a little bit bigger for you. I have declared 3 fields here, steer, accelerate, and brake, that maps back to what we created. And then what we are doing here in start is basically something new. We do input system dot actions, find action by name. So you can directly access those project-wide actions this way. You don't need a reference because input system keeps a reference on its own to that asset. And then we're basically adding handlers for performed and canceled. Why do I need both? It happens so that this game was built in a way that it basically operates on a sampled steering direction. So I want to know both when I press or change the steering stick here, or when I release it, and that's why we need cancel. Another option would have been to use the pass-through action, and we could stick only to perform there, but that's a detail. I didn't want to modify it. Similar on accelerate, we set up handlers, and similar on brake. So let's see what we actually do. So whenever there is input, I will get callbacks to these. And in the case of steer, we get a callback, which is passing a callback context. What I'm going to do is just get the value from that. And that is a vector 2, but I'm only interested in the x in this case. I steer left and right, not up and down. And on accelerate and brake, that's a button. So what I'm actually interested in is this here, because this kart script were designed in such a way that it want to know, am I currently accelerating? Am I currently braking? And that's why we check, is the phase performed? Is the button pressed? The reason why I check phase here is because that's a more abstract way to look at an interaction. So that's it. I think this would actually work, so let's try it. Just gonna make sure I'm connected to my gamepad here. Yes, I seem to be. Do you think this would run on mobile?
Yeah, let's go for it.
Let's try that. Yes, give me a minute. So I'm going to try to show you live as well. What I built is exactly the same thing. I did it just before the talk and uploaded it to the phone. And I recorded it here for you as well so you can see it. So without doing any kind of changes, we can already play this game on mobile. Isn't that awesome, Cristiana?
I think it's awesome, but I would rather for our game to not use a gamepad. Do you think we can just put it on the phone?
On a phone? I mean, sure, maybe not everyone has one of these in their back pocket. Or do you? Traveling the bus, eager to game, pull this one up. I mean, it's great you can use the actual gamepad on the phone like that, but yeah, I get your point. It might not be for, we might not reach such a big crowd using it like that. So, what if we try to translate a gamepad-like behavior to the phone instead? So, we could do kind of what we configured there from the beginning, that we use a stick to steer the car, a button to accelerate on the right-hand side, a button to brake, and maybe a button up in the corner like that to access the menu. So, what do you think about that?
Let's go for it.
All right, let's jump into the editor again and see how we would go about building that. So back in the editor, we have already seen that there are some UI elements in place in this project. So let's see how that is set up. And there should be a prefab for that. So I'm going to open that one in isolation. So we have something like this, and we can see that this is a number of canvases that already exist. So it's Unity UI canvases. And I prepared a canvas here that we can look at to see how we could, as easily as possible, build some on-screen controls. So I'm going to turn that one on. And what we will see now is that on this canvas, we placed some other UI objects. And as you might see in the inspector here, it's basically just an image. And we used anchoring to get it in the corner that we want. And what we can also see is that on this canvas, we have a canvas scaler. And we can see that that is set to constant physical size. Equivalent exists in UI Toolkit as well. And that is key here, because if we design on-screen controls, we want them to translate across devices. The size of a device changes. We know that. It might be a laptop with a touchscreen, it might be a tablet, it might be a phone. But of course, our thumbs are not going to grow extra long or something like that, that we can play with a huge tablet unless we scale it correctly. So we want the buttons to have the same size regardless of what device we're using. So for example, if we pick a certain look at that. Something interesting is happening here with the screen sharing, so I think they get extra small. But if we look at how we would configure it, let's go back to this stick that we looked at here. So it's currently just an image, but what if we go here and add some components? So if we go to Input and go to Input Screen Stick, this is a ready-to-go component as part of the input system that allows you to configure an on-screen stick and basically affect how it behaves. So first of all, there's going to be a movement range. I'm going to put that on 25. Next thing is a control path. That basically allows us to set what will this stick behave as. And in this case, I'm configuring it as a gamepad left stick. So what this would do is that when you interact with these on-screen controls, it's going to generate input that looks like a real gamepad. And that means that if we already have an action binding for a gamepad, we don't need to do anything more. And I'm also going to put this on exact position with dynamic origin. And that means that where I put down my finger, it will recenter itself to have its origin where the touch starts. And then the range for that movement, let's put it at 25. And then we take our next element, which is an accelerate button. And similarly, we're going to go to Input and then go to on-screen button. And this component instead only has a single property, control path. And in this case, we want this to be button south on a gamepad, because we want this UI element to trigger the same action as we configured in our project settings. If we recall and just have a look here, we had this accelerate and button south. So we're going to use that. And similarly, I have already configured a brake button and a menu button. So how would this play on a mobile device? Let's create a build of that and have a look. Let's see. I'm going to start this here as well. So now we instead have on-screen sticks, and we can, on the left-hand side, we can steer, and on the right, we can accelerate, and we also have a brake, and we can access a menu. So I think that would work a little bit better and reach a far bigger audience. Or what do you think, Cristiana?
I think it's really fun to play. The controls seem very responsive. But I do wonder if we could make it even more fun.
What are you thinking?
Well, usually racing games do really well with motion controls. So I do wonder if we could just allow the players to stir the phone and that way control.
Ah, cool. So like something like this.
Yeah?
Like a wheel.
Mm-hmm.
Interesting. Yeah. I think we could. I think we can use an attitude sensor to achieve that. And if you're not familiar with it, an attitude sensor is a composition of 3 other sensors: a compass, a gyroscope, and an accelerometer. And good for us, most mobile vendors have combined these depending on their particular implementation and offer us something that's called an attitude sensor, which typically, at least in Unity, we present that as a quaternion, or it might be 3 axes. But the interface we provide are a quaternion. And that allows us to reason about how the device is positioned in world space, the real space. And that's very useful for this. But to achieve this particular feature, we also need to do a little bit of work. So I'm thinking about something like this. First of all, if you're using input system, all sensors are off by default. That's not very convenient, but of course they should be, because a sensor on a handheld device that uses a battery, of course, we don't want to drain that battery in vain, so we need to enable that sensor first. Next thing we need to do is that we talked about this sensor giving us orientation in space. But that means we also can translate that very easily to our simulated space in the game. So what we can do is instead transform the problem a bit. So we establish a reference orientation. So let's say, for example, when the game starts, we check what the current orientation is. And then, based on that, read continuous values of our orientation and compute the difference between those two. So if I would start in this position and then turn my phone, we could notice what was the difference across all angles that movement would yield. So if we do that, compute the difference, and then pick some vector, for example, the y-axis, and then we rotate that vector by that differential quaternion, we could figure out how that axis would rotate and then project it down on the x-axis to get something that would resemble the steering we already had in place. So a little bit of work, but hopefully it will get the job done. So let's try to build this, or what do you think?
Absolutely.
So we're jumping back into the editor. And this time, I'm going to go into project settings, because this is going to be a little bit different. So I think the best way to deal with this would be to create a new action. And let's call that tilt. And we're going to set its type this time to pass through, because we're not really interested. It would be a bit weird even to think about this rotation to being actuated or not. So we're just interested in all values. So we're going to use pass-through, and then we're going to add a binding to this. And let's pick one here. And we forgot one thing, I realized. So let's go back to our tilt. And we're going to put this to quaternion to only see bindable controls of that type. And then go here and look for attitude. So now we bound this action of type quaternion to an attitude sensor. So that's good, but we also need to do some more work. So let's jump into our code again and look for this new action. And I'm going to go input system.actions.find action and tilt. And let's add a handler to our performed action. So it's very similar to before. You might have noticed that how can tilt be defined and how can this tilt to steer be defined? I actually prepared those two functions, or the variable and the function. So let's go down and see what's going on here. So similar to before, there's an input action called tilt in this case, and then we call this handler tilt to steer. Similarly to before, we're basically fetching the value, in this case a quaternion. We pass that to a function called compute turn from attitude. The whole purpose of that function is to give us back a float here that we can just pass to this existing function to steer. And what is going on here? Well, basically, this is just the code representation of what we just talked about on the slide. We first check, do we have a reference attitude? If we do not have that, we're going to check, is it a valid quaternion? And this is one way to check if it's a valid value, because if you start a sensor, it might not give you reliable values from the get-go. But if it's valid, we're going to set a Boolean flag to true, and we're going to store that reference orientation. As soon as we have a reference orientation, we're going to do this other computation every time we get a new value. We're going to compute the inverse of that reference and do a star operation with the other quaternion. That will give us the difference. And then we're going to rotate our vector up, which is the y vector, with this difference, and pick out the x projection there, and then clamp it. Why are we clamping it? Because maybe we want to put a limit on how far you should be able to steer this car. And then we return the value. So a little bit of math happening there, but hopefully it will work all right. So let's see how that plays on mobile. So what's different now is that I can rotate the phone. As you might see there, I can rotate the phone to steer either left or right. We still have the buttons intact for accelerating and braking, but we really changed and transformed how we interact with the car. And to be honest, out of the different ways we did this, I found this one the most fun and engaging. So, I think we're done. Are we ready to ship this? Or what do you think?
I think it's time to test it with some players first.
That's awesome. So, let's just summarize what we've seen here. We started to just pick up the project-wide input actions. We modified them a bit. Those already contains binding for gamepads, and we got that up and running in the editor. And then we took it one step further. We realized that, okay, this is not going to translate to a lot of users. So it's great, you can use a physical gamepad on mobile, but you had a good point, Cristiana. Let's do on-screen controls. So we built that without writing a single line of code. We used the existing on-screen stick and on-screen button components and got the job done. And then we finally explored using sensors, and we changed how you steer this car. And that might be, there are many sensors today on mobile devices, and that can be a way to add some interesting aspect, or at least an optional way to control something to make it a little bit more interesting. So, I hope you agree that doing some small tweaks, but still relying on the same abstract representation of input, we can do it quite differently and add in elements to support a range of platforms where you use different kind of devices. But the input system can do even more, right?
For sure. Thank you, Håkan, for walking us through the demo and really for showing us what the input system can do for our karting game. Now let's take a look at some other features that might be useful for your future projects. Really, one of the key features of the input system is that it has subframe resolution of events, and events are timestamped. And this allows us to reason about the order of events. And I have a diagram for this. So first, let's take a simple scenario. One button is pressed per frame. Both input manager, older solution, and the input system would do well. But what if we take a more complex scenario? Let's say that 2 buttons are pressed per frame. So scenario 1, button A is pressed first. Scenario 2, button B is pressed first. Well, in this case, with, let's say, the input manager, which has frame-based fidelity, we wouldn't be able to tell whether button A or B were pressed first. But with the input system, we can. And why is that relevant, Håkan?
Yeah, it's a good question. This might not have a huge impact on a game like the one we just created, or for any kind of game that's a bit slow-paced. But as soon as there's quicker movement or certain sequence of button presses are expected. Let's say a fighting game where you might have combos where one combo might start with AB and another one with BA, then all of this matters. This also matters, of course, if your achievable FPS is, or frame rate per second, is much lower, because the longer the frame, and if you have a lot of input during that frame, you will not be able to differentiate these two scenarios unless you have subframe resolution.
Absolutely. Next feature is extensible device support. With the input system, you have access to input device reports, enabling you to extend the system with decoding capabilities for niche or unsupported devices. You can also leverage built-in processors like Dead Zone or create custom ones for your games. And last but not least, we also support local multiplayer scenarios with a minimum amount of effort by using the player input and player input manager components. And today we've seen that the input system has some great features, but really this is to make the point that the power of this tool lies in what you as developers can build with it. So really, we encourage you to use it in your future projects, experiment with it, and while you're at it, also write in our discussions page, because we're always seeking your feedback. Thank you.